This lecture goes over the conceptual understanding of density and simple calculations involving density. What is density? Well, basically it's how much stuff, how much matter is packed into a certain volume in space. The more that's packed in, the more matter that's packed in a certain amount of space, the higher. So the units for density are mass divided by volume. And again, the most common units would be grams over milliliters. Why do we care about density? Well, one of the reasons is when we do a chemical reaction, we want to know how the different components of a mixture will interact with each other, or certain engineering processes. We want to know if something's going to float or sink, and because we have defined the density of water as exactly 1 gram per milliliter, that's a good comparison for almost anything. If we see something float in water, we know that the density of that object is less than 1. If something sinks in water, the density is greater than 1. So here's the formula for density. Density is mass divided by volume. Again, I'm going to reiterate what I did in the last lecture. It's very important throughout this course to know that 1 milliliter is the exact same thing as 1 cubic centimeter. They are equivalent. Density is also used to identify a substance. Let's say you have a chunk of metal and you have no idea what kind of metal it is. You might be able to measure the density and identify it from that. So here's kind of a handy-dandy little crutch for calculations with density. If you're comfortable with algebra, you can ignore this, but I've kind of noticed there's some people who just don't get algebra, no matter how much they try to work with it. And as a teacher, I've noticed that, so I've tried to come up with tools. So this is the magic triangle when you have a formula that has 3 variables, like let's see, density equals mass divided by volume. So in this triangle, whatever you're trying to solve for, you cover up. So let's say I'm trying to solve for density. You put your finger over that part of the triangle, and density is mass divided by volume. Let's say that instead of solving for density, I've been asked to rearrange the formula and solve for volume. Well, whatever you solve for, you cross out, take away, and what are we left with? Volume equals mass divided by density. And if we are solving for mass, okay, cross out mass, and mass equals density times volume. Okay, so I'll give you these magic triangles whenever I can. Preferably, you're comfortable enough rearranging algebraic equations like this so you don't need the triangle. If you'd rather memorize the rearranged formulas, here they are also, but you will need to be able to do all of these variations of this calculation. Okay, so for example, here's an example problem. The mass of an object, this is the simplest type of problem you can get. It's 35 grams, and what is space? It takes up space. Space is volume, okay? So they're basically giving you density equals mass over volume. Mass is 35 grams. Volume is 7 cubic centimeters. So the density of this is 5 grams per cubic centimeter. Okay, so that's a straightforward, simple calculation. Here's another one. This one you have to think through. So what I'd really like you to do is, because problem solving ends up being probably the most challenging part of chemistry for most students, I want you to go ahead and read this question, then put the video on pause and see if you can work it out yourself before you see the answer from me. An empty container, so I'm just going to draw a container, is 121.3 grams. Okay. When it is filled with carbon tetrachloride, I know you probably don't know how to write formulas. That's okay. It is 283.2 grams. So now they're saying, what is the volume of the container? So again, if you think you have an idea of how to do this, go ahead and turn the video off and try it. Otherwise, I will begin working through it. Well, the first thing I would tell myself is we're solving for volume, so I need to rearrange my density equation to solve for volume. When you rearrange this algebraically, you get volume is mass divided by density. So, do we have the mass? Of the carbon tetrachloride? Which of these masses do we use? Well, you want the mass of carbon tetrachloride, right? That would be the difference between these two. So 283.2 grams minus the mass of the empty container will give you the mass of the carbon tetrachloride. So here's the problem worked out. As I said before, the mass of the container and the carbon tetrachloride was 283.2 grams. The mass of the empty container was 121.3 grams, and so if you take that difference, you find that the mass of carbon tetrachloride that it took to fill up that container is 161.9 grams. Here's the density equation rearranged to solve for volume. We just solved for mass, and the problem gave us the density of carbon tetrachloride as 1.53. And so the volume of that carbon tetrachloride, you simply do the math here, and you find that the volume of carbon tetrachloride that it took to fill up that container is 106. Notice that grams cancel out, and so the units you have are cubic centimeters. Remember, that's the exact same thing as milliliters. Right? So that is your answer.